So let's talk about active versus passive elements and independent versus dependent sources. Active elements are capable of generating energy to the circuit. Voltage and current sources are good examples of this. Passive elements are not capable of generating energy to the circuit. Resistors are a common example of this. Independent sources are active elements. They provide a specific voltage or current that is independent of other circuit elements. They are illustrated with circles. Independent voltage sources have a plus and minus symbol indicating their positive and negative terminals, and independent current sources have an arrow indicating the direction of current flow. Dependent sources are also active elements, but they are controlled by another voltage or current source. Dependent sources are illustrated with a diamond shape. A dependent source can be one of 4 types. It can be a voltage-controlled voltage source, a current-controlled voltage source, a voltage-controlled current source, and a current-controlled current source. These values are examples of how dependent sources might be labeled or valued. It should be noted that an ideal voltage source, either dependent or independent, will produce any current required to ensure that the terminal voltage is as stated, whereas an ideal current source will produce the necessary voltage to ensure the stated current flow. Here's an example of dependent sources and how they relate to voltage, current, and power in a circuit. So for this example, we have an independent voltage source, we have a dependent current source, and we have 2 passive elements. So firstly, it asks, is there a dependent source in this circuit? If so, which type is it? Well, we've established that we do have a dependent current source right here. And now let's think about what kind of dependent source it is. Well, we see that it is a current source, right? Because of the arrow, and this is going to be the flow of the current. It's going upwards here. And we see, obviously, that it is a dependent source because of the diamond. And we see the value here is 0.2 I. We can tell that I, the current, is the variable used to control this dependent current source. Therefore, it is a current-controlled current source. Right? Or CCCS. And so the second question here, it asks, given that I is equal to 5 amps, how much power is supplied or absorbed by each element? And by that, it means how much power is being supplied or absorbed here by this element, this element, this element, and this element. Okay, so we're going to have to find P sub 1 through P sub 4. I'm going to duplicate the image here so we can work with it. And we know that the formula for power is voltage times current. So let's find P sub 1. Well, at P sub 1, there's going to be a voltage V sub 1 at that element, across that element, and a current going through that element, I sub 1. What direction is current flowing at P sub 1? Well, we can see that I here is coming from the source, right? And so I must be flowing this direction across the element. And we can see that the current is flowing in through the negative terminal, which means that our power is going to be some negative value right here. It is given that V sub 1, the voltage across this element, is 20 volts. And I sub 1, we already know here, it's also given that it is 5 amps. Therefore, this is equal to negative 20 volts times 5 amps. Therefore, P sub 1 is negative 100 watts. Now, if we have a negative value for power, we know that power is supplied. And in this case, it's being supplied by the voltage source. Now for P sub 2, we have that P sub 2 is equivalent to V sub 2 times I sub 2. And for P sub 2, the current is entering the positive terminal of the element. Therefore, we have a positive value here. And for V sub 2, we have the given value of voltage, which is 12 volts. And for I sub 2, which is equal to I, here, that's the current going through it. That's equivalent to 5 amps. That was given already. And so we have that P sub 2 is equivalent to positive value of 12 volts times 5 amps. Therefore, P sub 2 is equal to positive 60 watts. And because it is positive, we know that power here is being absorbed by the resistor. Okay, I'm going to copy the image again. And for P sub 3, we have that P sub 3 is equivalent to V sub 3 times I sub 3. We see that current right here is going down into the positive terminal of the element, and therefore this would be a positive value. For V sub 3, we have a value of 8 volts across the element, and I sub 3 is given here. It's equivalent to 6 amps. That is the current going through the element. And so P sub 3 is equivalent to positive 8 volts times 6 amps. Therefore, P sub 3 is equivalent to 48 watts. And this power is positive. It's a positive value. Therefore, it is being absorbed by that element. And lastly, we have P sub 4 equivalent to the voltage across that element times the current through that element. And we can tell here at P sub 4 that the current is going that way. It's going upwards. Now let's take a look at this. This is entering the positive terminal of the source or the negative terminal of the source. Well, the direction of the arrow here states that the head of the arrow will be the positive terminal of that current source, and this would be the negative terminal of that current source. And since the current is flowing upwards, we see that current is flowing up into the negative terminal of the element. Therefore, this value would be negative. And so for V sub 4, let's think about what the voltage is across this element here. Well, we see that this element is connected to the same nodes as this element, which has a voltage of 8 volts. Now, if two elements are in parallel, which is what these two elements are because they're connected to the same two nodes here, it means that they have the same voltage drop across them. And we're going to talk more about series and parallel elements in Unit 2, but for now we're going to take for granted that the voltage here is going to be equivalent to 8 volts. So V sub 4 is equal to 8 volts And I sub 4, we see the value here is 0.2 I. And we know that I here is equivalent to 5 amps. Therefore, P sub 4 is equivalent to negative 8 volts times 0.2 I, which is equivalent to negative 1.6 I. And since I is equivalent to 5 amps, we multiply it by 5 amps. And we can conclude that P sub 4 is equivalent to negative 8 watts. And because this value is negative, we know that this power is being supplied, which makes sense since it is a current source. Even if it's a dependent current source, it's still a source, and that has the ability to supply power to the circuit. This lecture is included in Unit 1 of our electric circuit analysis series, where we cover basic concepts including charge and current, voltage, and power and energy. The formula sheet for this entire unit is available for purchase at payhip.com/EngineerPeer. Right now, all our formula sheets are on sale for 50% off.